Hello, I'm Roman. Welcome back to the series of the videos Neural Networks from Scratch, where we using this book, but we writing everything with the Golang. Currently, I'm at chapter 18 already. That is called model object, and in this chapter we are implementing the model. Well, not class. We're implementing the model object that will be responsible for, well, it will encapsulate all of the logic about model training and prediction, I think. And currently I'm at this stage. So what I did in the last video, I started to implement the forward method that, well, there are a couple of things. First, um, first, if we take, no, this one. If we take a look here, we have the model definition. We can pass the loss function and the optimizer into the model. Then, well, we can print the model description, but I need to improve this. There is a method to finalize model setup. Right now, it's mostly empty because my implementation is a little bit different from what the book provides. This is because of the difference in the Go and the Python. And there is a train method that currently does pretty simple thing. It calls forward method for the model. And the forward method for the model will call the chain of calls of the forward method for all of the layers. By layer, I mean everything that inherits the layer interface, which is actually two things. We can take a look. This is, well, okay, I cannot find the, so basically the layer interface is implemented by all of the activation functions. So I will show everything quickly. So by all of the activation function, there is no, this is the thing that I don't like about the Go, or I just need to get used to this. It's like there is no explicit uh, conformance to a specific protocol. So for example, if I implement all of this function, then I automatically conform to a specific protocol, which, I mean, I understand pros and cons. For me, it's just I need to get used to this. Because right now I don't understand how I can find all of the structs that implements a specific interface. And the same, we have the layer. We have three layers at this moment. I need to add the input layer, but it's actually, right now, I don't think I need this. Well, I mean, I don't think I need it to conform the layers input protocol because what? Because model. Because if you take a look at the forward method, I need to have this check that if we, at first iteration through our, to on going through our model, I need to take the data from the input layer, which basically just a training data that I passed into the model, and else I'm going this, well, I'm using this chain of the layers. And in the end, the forward method returns the last output from the last layer, which, for example, in the example that I wrote right now, is the linear activation that will basically copy the results from the previous layer and pass it. But it means that I can use this method here to calculate accuracy and the loss. And this is, I think, the next part that I'm going to do. As I told before, by the way, this video will be shorter than usual. I will need to go earlier. So maybe it will be around 30 minutes, 30, 35, something like this. So we have the finalize method. We have this. I'm not going to write like saving the training layers. This one, because for me, it doesn't make any sense as the layer interface actually represents the trainable layers. in my case, because here, if you take a look, there is a um, in the layers you can add different things. For example, you can set the next as loss, the pref as the input layer. The next thing, next will modify the common loss to contain the following. And my question was, well, regarding the goal length specifically, can I implement a function for the interface? Because if I can, that makes things easier. So let's try. Um, because if I can, I will move the loss interface into separate file. It will behave like a common class, like the base class for other loss functions, but we'll have some stuff in this. Basically, I don't need this. Well, actually need this because I need to pass the reference to the layers array, but the main thing is that I can move the calculate into this. So let's try. What it could look like. I could have loss interface. It should be like set layers, and that will be layers. It will be a reference to layer dots. No, it's actually will be like this, right? Pointer or interface type. Mm. Mm. So I cannot. Well, that suck. Okay, I will Google. Well, okay, I think that works. I think that works for me. The main reason is to add basic implementation, right? So that means, okay, if I go to the loss, base loss, loss, type base loss, struct. And then I'm thinking, should it hold something? What I had. Okay, so it will actually hold the inputs, right? I can move it into base loss. And then I can implement, well, actually the second one is layers that will be reference to the slice of layer interface. Layer interface. Model layer interface. Okay. Okay, this stores the inputs. Then what I need? I want to have the base. Okay, first. I have the loss as base loss and will be set layers. And be a layer down. That I think should work. We'll have loss layers equals to layers. Then I have the calculate, and the calculate should be okay. Let's take the calculate from this one. Right? So that would be base loss. Mm. Mm. Yeah, this is. Yeah, there is a problem that the base loss should have the forward methods, but it hasn't. I can pass. I think one of the things is I can pass the function that will calculate this for me, right? I mean, the exact function with the concrete declaration, right? So what I need to understand, I need to understand how the function declarations, right? How it will be forward, it will be fn. How this, I think, apply. Okay, fn func. Okay, so in my case, it will be forward func that takes that's interesting. Do I need naming target before, and it returns what it returns? Forwards for the loss. No, it's activation for the loss returns float 64. So here it will be float 64, right? Mix name and the name. Okay. So that will be again prediction target. Okay. Then it means the sample loss is equal to forwards prediction targets. All right, presents array. Not one specific, but a slice. A little bit weird way, but I'm thinking how I'm going to use it. For example, I will replace this with, for example, mean square progressions. Hmm. Okay, I'll pick this later. Mm. I mean, okay, if I will use the composition of the structs, for example, I will have the base. I will have this weird calculate function that takes forward, but I still need a function that will call this calculate and pass an appropriate forward, which means, and I still have the loss interface, right? I mean, I can do this. I mean, like every loss will use the calculate. I mean, this one, and it will call the calculate from the base class and pass the forward into this. I mean, sounds, I mean, feels like it's easier to just copy paste this thing in every loss class and that's it. Or maybe I can move it. Actually, maybe I can make it as a generic, well, not generic, maybe I can do it as a function and just use it and drop this strange. All right, so let's remove it now. What I will do, I will actually have the accuracy that, well, we will have actually the different accuracies. So here, I think I can do this, right? Um, and it should work. Base loss and base loss. Okay. Okay. Then, I mean, I can put the calculation of the, I mean, we're putting it into the loss, but I don't think, I mean, yes, it makes more sense to, oh, what I can actually do, I can, oh, I think I got it. Base loss. What if I can do calculate loss? And there will be several. Well, first it takes the loss as, what is it called? Loss interface. Yeah, I think I need to move the loss interface into the loss because it kind of makes no sense. Because right now I have the circular dependency between the packages, between the loss and the model. So it's not good. But what it means, then I have the output, which will be dense. And for now, I will have the target, which is float 64, and it will return, what calculates, I think it returns the value. Then, yes, I will do this. But instead, okay, it's the predictions, prediction, and targets. Loss forward and define type model is a pointer to interface, not interface. Okay. Right. Mm, Command go. Then what I'm doing, I'm taking it here. I have the loss. Then Yeah, there is no need to put it here. Layer interface should be, I think, in the layer. Right? Common go. Mm, I will ignore the fact that activation is based on the layer. For me, that's fine. So, okay, I don't need this. Okay, and I actually need, I can put the optimizer here. Um, mm, optimizer, right? So then, okay, models. So layers interface comes from layer now, right? Loss interface comes from the loss. Hmm. Hmm. Layer loss import cycle is not allowed. Why we have the cycle? Not important. Because it's not in the model, it's in the layer right now. And same here. Let's take a look. This one, I don't need to import this. Layer interface is defined there. Base, there's calculate loss. Loss interface comes from this package, predictions. Okay. Then I have errors in the model. Could not import main loss, missing metadata for I. Expected package found in the file loss. Okay. So right now, okay, it works. Hmm. Rain, right? So why I did all of the things. So I have the calculate that will operate loss. I'll have the calculate loss that will take the loss interface, base, base. Okay, I think that's fine. That's the part of the base loss struct. Okay. The remember trainable layers method in the common loss cause tells the loss object to which layers in the model are trainable. The calculate method was modified to also return the self. Calculate method was also. Oh, right. Okay. And I need to calculate the regularization loss, but can regularization loss be a part of the base loss? Hmm. Okay, so regularization loss is calculated on the layer. What I can do, I can go into the base, but now it will call the regularization loss. The only difference, it will use base loss. Regularization loss. We have the math. And instead of just checking it for the one, I will check it for all of the layers, right? So I don't need to specify it, but what I can do this for layer equals to range loss layers. Cannot range over. Why? Why you cannot? Okay. We're removing this, and I move it right down here. Okay, it means that the layer interface should have L1 and L2. Okay, but it works only for the layers, right? Okay, so they actually store in the layers, right? Okay, maybe then it makes sense to have the trainable layers. What it means then? Yeah, it means that it won't be the layers interface, it will be layer, right? And then here, layer, then it will work. But how? I need to change the finalized model here as it was in the book. I need to check if it's I need to do the downcasting. Can I do this? Because the add works with the layer interface and it takes downcasting. Okay, colon downcast from interface. Can I do this? use a type assertion, for example. Entity. So you tell me that I can do this for item range layers. Oh, so I need to have the trainable layers because I will need to pass them into the loss, right? So wait, trainable layers also to make layer um, 0, and then how it's done, original uh, layer og equals to item dot layer. Okay, if awk, then trainable layers append layer. Can't use variable after this. And I think yes. The result of append is never used except maybe in other appends. What do you mean? Okay, and then I should have loss function and I should have set. Wait. And I should have set layers. Set layers, trainable layers. Loss interface. That will be this one, right? Right. It should be array of references. Here it will be the same, and here it will be the same, right? Right? Finalize. Okay, so it means that at this moment we should have the trainable layers set up into the loss function, right? Then the regularization loss will operate on top of the base loss, which means that all of the loss functions will have this and they will work specifically with only layers. Okay. It's okay. For calculating accuracy, we need prediction. So far, predicting has required different code depending on the type of the model. For softmax classifier, we do np.argmax But for regression, the prediction is the direct output because of the linear activation function being used in output layer. Ideally, we could have a prediction method that would choose the appropriate methods for our model. To do this, we will add predictions method to each activation function. Okay, predictions. Okay, and then I think we'll get the going to integrate. Okay, let me check the recording. Okay, that's all for today. I'll continue tomorrow from the predictions, well, from the implementation, the predictions accuracy. But yeah, I think it will probably take me 2 or 3 another episodes, because right now I'm doing lots of the refactoring. I have no tests and I need to change some of the loss function that they implemented before, specifically for the example that we had in the book, but I will need to make them more generic. And I need to tweak the data generation functions. Yeah, so most likely I will have bugs and I will need to debug it. This is why I'm thinking another two or three, uh, what's 2 or 3 episodes. But that's all for today. Thank you for watching and I see you tomorrow. Bye bye.